Well, hey there, kiddos, and here is your video over adding and subtracting polynomials. But before we jump into that, we've got to do a few definitions. So on the back of your agenda, and this is going to be part of your notes check tomorrow. If you don't have this, you won't get all 5 points. So on the back of your agenda, we need to take down some definitions. We're going to start with the word monomial. A monomial is a product, so it means multiplication, of a number and variable or variables. It could be one variable, it could be 3 variables, it could be a variable or variables. So it's several of them. So an example of a monomial would be 5x. Another example of a monomial would be 3x squared y to the third. Those are monomials. Okay, it's got a product of a number and then the variables. Usually the variables have powers. The next definition is something called a binomial. A binomial is the sum or difference of two monomials. So what happens when you have a binomial is you have your two monomials, and they are either added together or subtracted. So a binomial has a plus or a minus sign involved. A trinomial, just like a binomial, instead of it being two monomials, it's 3. So it's the sum or difference of 3 monomials. Difference of 3 monomials. And so again, it also contains plus or minus signs. And so it usually looks something like this: x squared plus 3x minus 1. And then a polynomial covers all of these. So a polynomial occurs when you have 2 or more terms or monomials in your statement. Okay, so it is the sum or difference, or that's the word or, the sum or difference of 2 or more monomials. So a binomial is considered a polynomial, a trinomial is considered a polynomial, and anything bigger than that, so if it's got 4 terms or 5 terms, 4 monomials, whatever, those are considered polynomials. A monomial, there's just one of them, so it's not considered that. So now let's look at your notes that are in your packet. So number 1, I want you to circle the true statements, and you're supposed to write an explanation for why the false statements are false. You can go back and write your explanation after this. We're just going to find the true statement. So statement 1 says a monomial is a polynomial. Statement 2 says 4a cubed minus 7 is a trinomial. Statement 3 says a binomial is a trinomial. And statement 4 says a polynomial has 2 or more terms. So we'll start with the first statement that says a monomial is a polynomial. And if we go back to our definitions, polynomial is the sum or difference of 2 or more monomials. And so a monomial all by itself is just 1. So this is false. A monomial is just a monomial. Number 2, 4a cubed minus 7 is not a trinomial, it's a binomial because it only has 2 monomials to it. These are called terms. It has 2 terms, so that's not it. A binomial is a trinomial. Well, they wouldn't have different names if they were the same thing, so that's also not true. But statement 4 says a polynomial has 2 or more terms. Yes, this is true. That was our very definition of what a polynomial is. It had 2 or more monomials or 2 or more terms. So we're going to skip down here to number 3 because this is what we're focusing on today anyway. Number 2 doesn't, it's a good question and we'll come back to it when we get to these kinds of problems, but for today it doesn't go with what I'm wanting you to learn. So addition and subtraction of polynomials. This is like adding and subtracting like terms. And so we did some of this before when we would combine things that were the same. And so if I write this out, and I want to simplify it, all of these have x's, and so I've got 2x plus 3x plus 4x. Since they all have x's on them, they're all the same thing, so I can add them together and then figure out how many x's do I have. Well, 2 plus 3 is 5, plus 4 more makes 9x. So as long as my terms look exactly the same, they have the same variables and the same exponents, I can combine them by addition or subtraction. So if you look at this first one, we have addition of polynomials, and we're going to have to add only things that look alike. If it doesn't have anything that looks like it, I have nothing to add it to. So our first term here is 5a cubed, and in my next set of parentheses being added is 7a cubed. Well, they both have an a cubed, so I have 5 of them, and then I have 7 more, so I get 12a cubed. You do not do anything with the exponents here. You're just trying to find out how many a to the third powers do you have. You have 12 of them. You had 5 and then 7 more. You're not doing anything with the exponents when you add. You just add the coefficients and call it a day. So now my next term is this 3a squared. And you see in my other set of parentheses after the addition sign, there is no a squared to add to that. So I'm just going to bring it down, plus 3a squared. And then I have this minus 6a plus this minus 10a. So I have negative 6a plus negative 10a. And if you need to check this on your calculator, feel free. But when I do negative 6 plus negative 10, that makes negative 16a. So I'm going to write it as minus 16. And then I have this 12a squared here that there's nothing to add it to. So I'm going to bring it down. But now look, I've got this plus 3a squared and this plus 12a squared. You always have to look at the symbol directly in front of the number. So this one makes this a positive 3, and this makes this a positive 12, so I'm going to do 3 plus 12. This minus sign here does not affect this 12. It's only a part of this 16. So you have to look directly in front of the number you're trying to add. So the 12a cubed, I'm not going to do anything with, but I'm going to do 3a squared plus 12a squared, which makes 15a squareds minus 16a. This is now simplified. So all I was doing was looking for terms that look alike, that look the same, and I'm combining them. Now you have to be careful when you are dealing with subtraction, because this minus sign right here in between means I have to minus all of these. So the easiest way to do this kind of problem is to take and rewrite it. So I'm going to rewrite this. I'm going to have 6x squared plus 8xy minus 3y squared. And then for this set of parentheses, it's like there's a negative 1 out here, and I'm going to distribute it to everything inside. So it's going to make this minus 2x squared minus 3xy, and then the negative 1 times the minus makes a plus 2y squared. So I have just distributed this negative to everything in here, and I've rewritten it this as one long statement. And the reason I did that is it's going to make it easier to combine things. So my first term is a 6x squared, and if I go down, I see that I also have a minus 2x squared. So if I do 6 minus 2, I get 4x squared. Then for my next one, I have this 8xy minus this 3xy, and if I do 8 minus 3, I get 5, and it's positive, so it's 5xy. And then I have this negative 3y squared plus 2y squared, and if I do negative 3 plus 2, I get negative 1y squared. You don't have to write the 1. You can write it as 4x squared plus 5xy minus y squared. These are the same thing. I don't care if you put the y or if you leave it off, but just know they mean the same thing. So this next one here, you have a picture of an angle, and it says to write a polynomial that represents the measure of angle ABD. Well, ABD is this great big angle that is the combination of these two. So I'm going to have to add these two together. So the first thing I'm going to do is write out what I have. I have 8a squared minus 2a plus 5 plus 7a plus 4. Now I'm going to add like terms. 8a squared has nothing to add with it, so it's going to stay 8a squared. But then I have minus 2a plus 7a. So negative 2 plus 7 becomes positive 5a. And then I have 5 plus 4, which makes 9. So this is the polynomial that represents the combination of those two angles. So now we're going to fill in this table. It's going to ask us to complete the missing statements. And so I'm given two polynomials and then ask for the sum, and then different information is given each time. So for this first one, I have x squared minus 6, and then I have 3x squared minus 10x plus 2, and I have to come up with the sum, which means I have to add them up. So I have to do x squared plus 3x squared. Well, remember there's an invisible 1 here. So 1 plus 3 makes 4x squared. And then I have this minus 10x in this one. I'm going to do it next because we like to go in order from most exponents to least exponent. So I'd go from x squared to x to the first to no x at all. So I would do this x next. Well, this minus 10x doesn't have a partner in polynomial 1. So it's going to stay minus 10x. And then I have minus 6 plus 2. So I have to do negative x plus 2, or negative 6 plus 2, which makes negative 4. So there is my sum. Now when we're doing the next two columns, I'm given polynomial 2 and the sum. I've got to find polynomial 1, which means I'm going to have to subtract these two. I'm going to have to take the sum minus polynomial 2 to get polynomial 1. And you don't have a whole lot of room to write, so we're just going to do this the best we can. So this is going to become a subtraction problem. So we're going to subtract. And I'm going to do this one thing at a time. So I have, and I'm going to go backwards. I'm going to start with the sum. So I'm going to do 3x squared minus x squared. I know it says plus, but remember we're subtracting. So if I do 3 minus 1, I get 2x squared. And then I have 2x minus x because it's subtraction. So if I do 2x minus x, I get 1x, and it's positive. And then I have 1 minus 6, and if I do 1 minus 6, I get negative 5. And so that should be my final answer. And you can double check it to make sure by adding this and this together and making sure you get this as the sum. So if we do 2x squared plus x squared, it makes 3x squared. And if I do x plus x, I get 2x. And if I do negative 5 plus 6, I get 1. So it does work. So this is the same kind of problem. I have polynomial 1 and the sum. To get polynomial 2, again, I have to subtract. So we're going to do that again, one term at a time. So I have 7x cubed and 7x cubed. Well, that just means they cancel each other out, so there's no x cubed left. Now this minus 6x has no partner over here, so it's going to be negative 6x to start. And then this minus 3 and this 11, I'm going to have to subtract them, so I'm going to do 11 minus negative 3. So it's 11 minus negative 3. So remember, these become addition. So if I do negative 11 plus 3, it becomes negative 8. So this is what polynomial 2 would be. And you can double check it by adding. 7x cubed with nothing x cubed makes 7x cubed. Then your negative 6x. I apologize. This should be positive 6x because we're subtracting. So this becomes, so if I do negative 6x plus 6x, it leaves no x here, which is what I want. And then when I do negative 3 plus negative 8, that makes negative 11. I have an issue. We're going to have to redo this problem, so let me pause and let's back. We're going to write this out so that we can see. We're going to end up doing 7x cubed plus 11, which happens to be the sum, minus polynomial 1, which is 7x cubed minus 6x minus 3. And so like I showed you in the problem in the beginning, we're going to distribute this negative to everything here. And so we're going to rewrite this. So we're going to start with 7x cubed plus 11. Then I got to distribute, so that makes minus 7x cubed. Then distribute here, this negative and this negative makes this plus 6x. And then distribute here, and the two negatives make plus 3. So again, the 7x cubes cancel each other out. That's still a thing. This 6x, though, is by itself, so that's why it's positive 6x, because I had minus a negative, and so that made it plus. And then when I do 11 plus 3, 11 plus 3 happens to make 14, so it's plus 14. And now when I add them, it will work out like it is supposed to. Everything is fine. It's still a subtraction problem, but I tried to shortcut this, and we shouldn't have shortcutted. We should have written it out like I did the second time, and now it works. So let's try this last question. It says the length of a rectangle is represented by 2x plus 3 feet, and its width is represented by 3x plus 7 feet. The perimeter of the rectangle is 35 feet. Draw a picture, then find the length and width of the rectangle. Well, it happens to tell you that it's a rectangle, and you know that the length is 2x plus 3, and the width is 3x plus 7. And so if I label all 4 sides, and then let's talk about how we find perimeter of a rectangle. There's 2 ways. You can use the formula. So the formula for perimeter of a rectangle, you can do 2 times the length plus 2 times the width, and that's acceptable, or you can just add up all the sides. I prefer to just add up all the sides. It takes all the complication out of it. I don't have to remember to multiply by 2. I just add up everything I have. That's why I labeled all 4 sides and not just length and width. I labeled them all 4 because then I add them all up. So let's add x's first. 2x plus 2x makes 4x, plus 3x makes 7x, plus another 3x makes 10x. So I have 10x, and then 3 plus 3 is 6. 6 plus 7 makes 13. Plus another 7 makes 20, so I have 10x plus 20. If you add that a different way, if you need to write it all out, that's fine. But it comes out to 10x plus 20, and they tell me that the perimeter is 35. Well, now to find the length and width of the rectangle, I now need to solve for x, and then plug it back in to find exactly what the length and the width are. So we're going to solve for x, so we're going to minus 20 from both sides. So I have 10x is equal to 15, and then when I divide both sides by 10, I get that x is equal to 1.5. And so I'm going to plug this back in. My length is 2x plus 3. So I'm going to do 2 times 1.5 plus 3. Well, 2 times 1.5 is 3, plus 3 makes 6. So the length of my rectangle is 6 feet. And then my width was 3x plus 7, so I have to do 3 times 1.5 plus 7. Well, 3 times 1.5 is 4.5 plus 7, which makes 11.5 feet. And so my width of my rectangle is 11.5 feet. So there's my length and my width, but the first thing I did was take my polynomials, my binomials, and I added them all up to find the perimeter, and then it equals 35 because that's what they told me it equaled. Solve for x, then plug it back in. So remember, when you are adding and subtracting polynomials, you do not add and subtract to the exponents. You're just trying to find out how many are there. How many x cubes do I have? How many b to the fourths do I have? How many of that variable do I have? You're not actually doing anything with the exponents. In this kind of problem, it's coefficients only. Add and subtract the coefficients, tack on the variable with its exponent, and that's it. So we'll practice this when I see you guys tomorrow. Have a good rest of your weekend.